Hello and welcome to today's webinar. My name is Tyler Reid and I am the Manufacturing Application Manager here at GoEngineer. And today we are going to talk about making clear parts clearer. Making clear parts clearer is a question that I get fairly often, and it's actually a process that is difficult to explain in person, so I thought it'd make a great webinar so we can go over the steps and talk about the steps in a little bit more detail and talk about which ones might be optional and which ones are you really going to want to make an effort to complete. So one of the first things that comes up when we start talking about clear parts is the idea that clear is sort of subjective. One person's clear is another opaque. Both FDM and PolyJet can produce, quote, clear parts. But what we're really talking about today are transparent parts. The difference between translucent and transparent is pretty key, especially considering a lot of our parts come off the machines as translucent, and then through some post-processing is how we get them to be what I would consider transparent. Translucent parts will allow light through, but they won't allow you to see detailed images from behind the part. So some material examples of translucent materials would be ABSI, which comes in amber, red, and clear. Think of like a tail light. That's an FDM technology. And then some semi-transparent materials on the PolyJet side would be like our Full Cure 720 and the Med 610 biocompatible material. I would consider those translucent, but with post-processing, we can't really get them to be transparent. The only material that I would try to make transparent from the Stratasys lineup is the Vero Clear material. It's really the only material that we could make optically clear. And that's what we're going to be talking about today. Something that's transparent is going to allow enough light through that you could actually see detailed images, words, and writing through the part. So I put together this transparency recipe, and just like any other recipe I've tried to follow in my lifetime, you don't have to follow it verbatim. So the basics are going to be things that you would do before the part is even really created. It's going to be, how are we building the part? What style are we choosing in the Object Studio software? PolyJet prints, when we go to print them, we can choose the surface finish. We can choose matte or we can choose gloss. If we choose gloss, the part is going to print with the minimum amount of support material. And anywhere where there's no support material, it will have this nice gloss finish. We use that a lot for models that need to look good or models that we might want to use for master patterns for molding or injection molding, something like that. Matte will actually coat the entire part with support material. So if it's a model that is going to require support material in some areas, sometimes we'll choose matte because it will give it a nice uniform finish throughout the entire part. And you won't have areas of the part that are matte because of the support material and gloss because of that's what we chose. Now, which is better for creating a transparent part? That's actually a tough question because it could go either way. So it's sort of the preference. A matte finish will actually give you better clarity, a more transparent part right off the machine. But it's going to have a rougher surface, so it's going to require more post-processing, more sanding. If you choose gloss, you might actually have a little bit more tinting, which we're going to talk about here in a bit, but it could require a lot less post-processing, so it's going to be a case-by-case basis. The build orientation also comes into play. So how are you orienting your part on the build envelope? You're going to have the best clarity through the Z-axis. So if there's one particular surface that you really want to make sure that you can see through, you're going to want to try to orient that so that the Z-axis is normal to that face. You're also going to want to pair parts that are on the same build tray with similarly height parts. Meaning you're not going to want to print short parts with tall parts on the same build tray if you're trying to make them both transparent. So the issue here is unnecessary or excessive UV exposure. If we have both short parts and long parts being printed at the same time, the short parts are going to finish fairly quickly, but they're still going to be getting hit with that UV radiation or UV light to cure the taller parts. And that additional UV exposure causes it to cure more, and that causes it to actually tint more. They'll have a more yellowish tint. So I would recommend, if you have an assembly with both short and tall parts, and you're trying to make them transparent, print them in 2 separate build trays. And then also, if you're choosing to print in a gloss finish, orient your part so that you're minimizing the support material. And that's going to set you up best for post-processing. And then lastly, for the basics, once the part has been printed and you've taken it off the tray and you've done your normal water jet process to remove the support material, you're going to want to go through some extra cleaning processes. Wiping this with propanol is preferred. We don't do this normally at GoEngineer, but it's in all the Stratasys documentation for preparing polyjet parts for paint. So this doesn't have to do specifically with transparent parts. It's just more along the lines of painting and surface prep in general. But propanol is a good alcohol-based material to coat these parts with. The sodium hydroxide bath is something that we do at GoEngineer quite a bit. A lot of people call it caustic soda or lye. But sodium hydroxide, we mix it in that ratio you see right there, 20 grams of soda to 980 milliliters of water. And we usually let the part sit in this bath after the water jet for 5 to 10 to 20 minutes. Not a long time, but that helps take a lot of the residue left over from the support material off the part. This isn't the best photo. I had a hard time getting a good photo, but I wanted to show the difference in clarity between the Z-axis and the XY axis. So you're looking at 2 parts. The part that you can actually see through, we're looking down through the Z-axis. So this would be looking down as if it was printing right now. And you can see, even though this part is pretty much unprocessed, all we've done is scrape the support material off the back side of the part. It still has pretty good clarity. You can see through it pretty well, and you can read sort of the words behind it. The part right below it, we're looking edge on, and it becomes a lot darker and a lot more cloudy. This is because we're looking through at a stack of layers, and the surface finish is not quite as good. The clarity is not quite as good. All right, the next step here is going to be one of the unique steps to polyjet. Some of these other things that we're going to talk about are just basic surface prep things that you might already know about, things like sanding and buffing. But this is something you might not know about because it's unique to the Stratasys polyjet technology, and that's photo bleaching. It's really a light treatment. So we talked about briefly the tinting of the materials. If the longer that part is in the build tray, the actual color is going to change because of the increased UV exposure. And color is actually tied to clarity. You can think of it like glass. A thin piece of glass is usually pretty clear, but as glass becomes thicker and thicker, a lot of times it starts to get a green tint. We have the same issue, but it starts to become a yellow tint. So this is a factor of 2 things. Part thickness, walls thicker than about 1/2 inch, a little bit more than 1/2 inch, 5/8, 15 millimeters, will start to show some yellow tinting. So you'll start to get more color in there. Thinner parts tend to stay more clear. And then also the part finish. If we choose matte versus gloss, this can affect the tinting as well. Gloss parts are going to be more susceptible to tinting because they have less protection from that UV light. Whereas if we chose matte, because it's coating the entire part with that support material, that helps block the UV light and we get less tinting. Photo bleaching is a way to deal with this tinting. The tinting naturally goes away over time, but we can reduce the amount of time or really rapidly remove that tinting by exposing these parts to fluorescent light. That's all this really is. You can see here the numbers. 6 hours of exposure, you're about 70% less tint. 24 hours of exposure, you're at about 90% less tint. We have just a little do-it-yourself setup here that I'm going to show a picture of soon, and this is the most common way to deal with this. 2 or more 45 watt 6500K fluorescent bulbs, pointing into a box filled with aluminum foil. That aluminum foil acts as a reflector so we can get light coming from all different directions. We try to keep the temperature around 100 degrees Fahrenheit. If it gets too hot in there, the parts tend to want to start to distort. And if it's too cool, the process doesn't work as well. We do pretty well with just the desk lamps with fluorescent lights that you can just buy at Home Depot. But if you're doing this and you want a more precise setup, something that's a little bit more consistent, there are commercial machines available specifically for this photo bleaching setup. Those are going to run you probably $1,300, where we built our box for, it couldn't have been more than $25. And it looks like this. All it is, it's a plywood box, some aluminum foil, a couple cheapo desk lamps, and then those two 45 watt, 6500K color temperature fluorescent bulbs. We don't always put our Vero clear parts in here, but when we do want them clear, or if they've been discolored quite a bit because they're thicker parts, we tend to pop them in here. Here's two parts. They're the exact same part. They're relatively thick. The overall thickness is approaching 1.5 inches, maybe 2 inches. So these are fairly thick parts. The one on the left has been photo bleached. The one on the right hasn't. So you can see it has a lot more yellow tint. If I were going to post-process these, it would be really difficult for me to have a fully transparent part without photo bleaching. So this is a step that can take a little extra time. If you print something in matte, generally you don't have to photo bleach it more than 4 to 6 hours. But if you print something in gloss like these were printed, you're approaching 18, 24 hours to get the maximum benefit out of this photo bleaching. All right, next step is sanding. Sanding really is the most crucial step in this transparent recipe. The good thing is that it's pretty approachable and it's cheap to do. The only thing it costs you is sweat equity. It takes a little bit of time, but you can find a lot of information about good sanding techniques and good processes. Generally, because of the polyjet, the quality of the polyjet parts off the machines, we really never go less than a 180 grit sandpaper. And I generally start with a 220 grit. And if I'm just trying to quickly sand it and I'm not really worried about the transparency, I will hardly ever go over 220. But if I'm doing a transparent part, then I usually start wet sanding at 500 grit, and then I bump up to 1,000 grit, and then sometimes even 1,200 grit. The difference between the grit is just the coarseness of the sandpaper. So I have an image up here kind of showing the differences here. We always start with the lowest number. This is the most coarse grit. Sand the entire part until we have a nice even surface finish. And at that point, we'll step up to the next step. If you progress to the next step too soon, what you might end up with is a situation where you're at 1,000 grit, but you're not really making a dent into some deep scratches because the 1,000 grit sandpaper just doesn't have enough coarseness to deal with those deep scratches. So some tips: use quality sandpaper. I've used a lot of different types of sandpaper over the years, and I'm a very frugal person. I usually cheap out on a lot of stuff, but sandpaper is one that I found I'm always frustrated if I don't go with like at least the 3M brand or higher quality, because the higher quality sandpaper is actually not gonna get gummed up. It's gonna last longer. It's not gonna start ripping as easily. So quality sandpaper is good. When in doubt, always start with the lower grit. So if you're looking at a part and you're not sure if you should start at 220 or 180 or even 120, just start with the lower grit. There's not really a downside other than the increased time of the extra step, but there is a downside of starting with too high of a grit. It's going to end up taking you a lot longer, and you're also going to be faced with the situation where you might have to go backwards. And then also, like I mentioned, only move on to the next grit when your current grit finish is uniform. Also, rinse the part with water after each step. Otherwise, you're going to start to get buildup, especially when you're doing the wet sanding. And when you're doing wet sanding, the wetness comes from basically just a soapy water mixture is something you want to do. The soap is pretty important because it helps lift that grit off the part so you're not just scratching your part. The question came up, which material would be best for printing lenses or light pipes? So really, we're talking about one material here. It's called Vero Clear. It's on the PolyJet machines. This is really the only material that's a good option for a fully transparent part. By the way, lenses are tough because lenses require a specific geometry. And because we're post-processing these parts, we're taking sandpaper to them. It's really difficult to control that shape as well as you would like to for a lens. But these will transmit light pretty well. So we're going to walk through the steps of making this panel that we're looking at fully clear. You can see this is a panel that I printed for a quadcopter that we did this year. You might have seen it in some other webinars. And I printed various panels. You see the Vero white panel on the far side, a carbon fiber panel that I did using an FDM layup tool. And then recently I printed a clear panel so you could see some of the electronics inside. And I just left it unprocessed for the longest time until it was basically time to do this webinar. So I went through my steps. Here's the unprocessed panel. We're looking at it straight on. This was a pretty good candidate to do for the webinar because it's relatively flat. The geometry isn't super complex. After going through the cleaning steps, I start hitting it with the sandpaper. One of the funny things about sanding, the ultimate goal is a transparent part. But as soon as you take sandpaper to it, it's going to start clouding up. So you're on the right track if it looks like you're going backwards. You can see here, this is after I did the 220. On the back side of this part, there's some raised areas that I didn't really do a great job of sanding around. You can see the finish is not quite uniform around those bosses. And then also there's still some deep scratches in here. I should have spent a little bit more time, and actually I should have stepped down in grit size. I probably should have started with a 180 grit or maybe even a 120 or 150 grit because it was just taking me too long. My sandpaper was too fine to get those deep scratches. But I trucked along. I stepped up to a 500 grit wet sand and then 1,000 grit wet sand. And this is the part after that 1,000 grit. You can see it's still just as cloudy. The surface finish is pretty much the same as after the 220 grit. If you could touch this part, it would feel different, but appearance-wise, it's relatively the same. It's much smoother. That's basically the sanding. After the sanding step, you're going to have a cloudy part if it's clear. If it's a colored part, it won't be so hazy. So then the next step in this recipe is actually the clear coat. The clear coat has an extremely drastic effect visually on these parts. As soon as you hit that part with the clear coat, it's instantly going to turn that hazy, cloudy surface into a more glass-like surface. So what's happening microscopically is when you sand that part, you're creating all these little ridges and troughs, and it's a little mountain, right? And when the light hits these angled faces, it bounces in all different directions, and that's what gives it that hazy appearance. When we hit it with the clear coat, it's this nice liquid coat, and it sort of evens out that surface finish. So now when light hits it, instead of getting bounced in all different directions, it's actually going to go right through. And that's the reason why the clear coat's so important. We definitely recommend a lacquer clear coat over any other type of clear coat. It seems to be the most friendly with the PolyJet materials. It is fast drying in general. And so we definitely recommend this over the enamels and especially epoxy-based paints. Some other nice things about coating these parts with lacquer just in general, PolyJet parts in particular, is the lacquer will actually increase the surface hardness. So sometimes we'll lacquer our jigs and fixtures and tooling and stuff like that because it improves the durability of the parts. It's going to actually give it the nice shine, makes it more easily cleaned, especially a part that you printed in matte that has a rough finish. It's going to want to tend to grab dirt, but if you hit it with lacquer, that liquid surface finish is going to become smooth, makes it a lot easier to clean, it's more sanitary. And then also, hitting this with lacquer is an excellent precursor to buffing and polishing, which is going to be something that we're going to talk about here in a minute, if you wanted to take this transparency even farther. So here's this same panel. The only difference between the last photo that we saw and this photo is one coat of lacquer. That's it. So this has great optical clarity. If I go back a couple slides, This is following the 1000 grit wet sand. This has been rinsed. It's ready for paint. 1 coat of lacquer is what you're looking at there. So it makes a huge difference. And in terms of important steps, this is definitely an important step for a transparent part. So the question came up, what about 2K paints, specifically the 2-part catalyzed paints? Are these okay to use on the clear parts? I'm going to say yes. And actually, they might be even better than the lacquer because my understanding is that they're going to dry even quicker because they're catalyzed. And they're probably going to be harder as well. I haven't specifically used the 2K paints, the 2-part or even like the 2K in a can paints. I've wanted to try them. I haven't. I don't think they're going to have a reaction with the polyjet parts. And so as far as durability and the quality of the paint, I think that would be a good way to go, the 2K paint. So visually, I mean, that's right where we need to be. And if you see this part now on the quadcopter, much easier to see it. There's still some scratches in there. And there's some orange peel in the paint. I just quickly did it in my garage. It was cold weather. It's not a good paint job. It did the job as far as making it transparent, but there's going to be some additional post-processing on this part to make it perfect, really to deal with the orange peel. And I might actually go back and start the process over to deal with some of those deep scratches that I neglected to address early on. That's one thing you're going to find in these refinishing processes is that if you move too quick, it's going to bite you. You're going to have to start all over and make sure you deal with the deepest scratches early on. So the last step in this recipe, I feel, is optional. It just depends on what your goal is for the surface finish. This could come after the clear coat. So coming back to this part, it has some orange peel. I might want to wet sand that and then polish it. And then I'm polishing the clear coat. I'm not polishing the plastic part. That's going to help me give me a nice sheen or shine that I couldn't get from the plastic part alone. Or polishing and buffing could completely replace the clear coat in some instances. It all just depends on what you're after. Polishing and buffing, they on their own, without the help of a clear coat, can produce optically clear surfaces. They're abrasive. They're going to require hands-on work. They're going to be a little bit more time-consuming than the clear coat. Polishing and buffing actually involves a lot of variables. You have different types of polishers and buffers. You can have a rotary tool, a random orbital tool, dual action tool, which does both of those, benchtop buffer. And then on top of that, you have different abrasives, pads, bonnets, wheels, in all sorts of different varieties and materials and coarsenesses. And then you have to use a lubrication or a compound. And again, there's dozens of different types of compounds. I don't have a lot of experience polishing and buffing, just pretty limited, and mostly with plastics. But what I've found for the Vero Clear, in most cases, or in my experience, the benchtop buffer with a wheel is usually going to be the easiest to work with. That wheel, the recommended wheel for plastics is something called a string wheel. They're not as common as just regular sewn cloth wheels, but the string wheel has a lot of just loose strings, like thousands of loose strings, that does really well with the plastics. And then something that's really well documented is that you want a blue compound if you're going to be polishing plastics. What I used is just a blue compound. I bought an AutoZone that's intended for refinishing headlight covers. That's all I use, nothing special. Some of the different variations, if you're not familiar with buffers or polishers, what I used for the parts that you're going to see here are basically the options on the left. A rotary buffer with a wool pad is what I used. In the center, you have a dual action polisher. Those are great because not only do they rotate like a grinder or a sander, but they also vibrate too. So you're going to get less likely to have swirl marks and stuff like that. And then the benchtop buffer is actually what I wanted to use. I just didn't have mine set up at the time with the string wheel, which is what you see there on the far right side. Benchtop buffer with a string wheel, I think, is going to be the best, especially for the parts I was doing. That would have been the best option. But in my case, I just used, like I said, the rotary buffer just sitting in my lap, and I moved the part on the buffer using a wool pad and then a cotton bonnet. And these are the parts that I polished. So These are two of the same parts. The one on the left is unprocessed. You can see it was printed in gloss. And we know it was printed in gloss because some of it's gloss. It has a half matte finish and a half gloss finish. So you can imagine the orientation that this was printed in. The left side was facing down. You also see some of the layering there on that top hexagon. This is sort of like a soccer ball, and it has some geometry printed on the inside. One of the unique things that we can do with the PolyJet is we can have these multi-material prints. So we can print something solid and encase it in clear. So that's kind of what we did. This is meant to be sort of a trophy. So that's what we started with. And then on the right is the result of the recipe we just went through, minus the clear coat. There's no clear coat on this. So it's the sanding at 220, the wet sand at 500 and 1,000, and I went up to 1,200 wet sand on that part. And then I put the blue compound on the rotary buffer with the wool pad and just polished it. So like we were looking at the panel, that 1,000 grit wet sand left a hazy finish. That was the finish of this part just before I decided to buff it. So we buffed the plastic, and you can see maybe a little bit better picture here. So the clarity is pretty good, but it actually kind of is a little dull. I'd like to have it more shine. So what I'm going to do is I'm going to clear coat this part and then go back and wet sand and buff the clear coat. And by doing that, it's going to give me a much better shine. But this is optically clear, and that's what this webinar is about. I wanted to show you guys this example here. It comes from my buddy David Garola. At the time he was with Grow It, which he eventually sold, and now he's with Stratasys. But it's sort of the same idea. He printed this in matte, so it's all the same surface finish as a starting point. I would have preferred that whoever printed these soccer balls would have printed them in matte. Even though it meant a little bit less post-processing on the gloss side, I would have preferred to start with a uniform surface finish. But anyway, he started with the sphere, and then he goes through the steps of just sanding. You can see it starts to clear up the haze a little bit. And then that last part, he says that it's just polished and buffed. I couldn't get that sort of shine, but I'm maybe not as experienced. It looks really good. You can see the reflection of the fluorescent lights up on the ceiling there. It looks great. So supposedly that's just sanded and buffed, no clear coat. That gives you an idea of what we're capable with on these Vero clear parts. That's all I had for you. Those are the steps, the recipe for making Vero parts more optically clear. There's going to be some work that goes into the pre-processing of the print, making sure that you don't pair short parts with tall parts, choosing between gloss and matte, making sure after you print them, you definitely do the sodium hydroxide bath, and a propanol bath would be nice as well. And then you're going to go through photo bleaching if you need it. You only need it if your parts are tinted. If your parts aren't tinted, like my panel, it was so thin, it wasn't tinted, we didn't need to photo bleach it. But these soccer balls that are about 3 inches diameter, they had some tint. So those were photo bleached for about 24 hours. Then you're going to go into sanding. You're going to step up in your grits until you get to 500 minimum, but you can go even higher, 1,000, 1,200, 2,000. Don't think you'd ever have to go higher than that. And then you're going to want to do a clear coat, lacquer, or 2K paint, and then polish and buff those with the blue compound. Your choice on the type of pad and tool, but the benchtop pad with the benchtop wheel with the string wheel would be best. So the question is there a 3D printer you'd recommend for Vero Clear material? So Vero Clear is going to be on the desktop PolyJet machines. The only machine that doesn't print in Vero Clear is the entry-level machine. It's called the Object 24. Every other machine will do Vero Clear, and they're all going to do it about the same. So you're not going to probably choose you're not going to choose a machine based on the Vero Clear material. You're probably going to base it on other things, some other materials or build size or something like that. Great thing about the Vero Clear is that it is one of the most basic materials. So for those of you watching on the YouTube, Thank you. Hopefully we'll catch you next time. Check out our other videos. If you have any questions, I respond to the YouTube comments, or you can shoot me an email or message me on LinkedIn. I appreciate it. And thank you guys for joining.